Write the electron configuration of aluminum. So whenever we have an electron configuration problem, the first thing you want to do is determine how many electrons it has. Since aluminum is an atom, it will have the same number of electrons as it has protons. So let's find aluminum on the periodic table. It's number 13, which means it has 13 protons. Since it's an atom, it's electrically neutral, so it will have 13 electrons as well. The next step is to put the electrons in the right energy levels. So let's look at our periodic table again. This is row 1, row 2, row 3, row 4, 5, 6, 7 of the periodic table. So each of these corresponds to the principal energy level. The first electrons are going to fill the first energy level, which is right here on top, energy 1. This right here, remember, is the S block. This over here is our P block. This over here is our D block. And this down here is the F block. Although this is more complicated and people don't really care about the F block, except for some people really care, but most people don't. Okay, so the first energy level only has an S block. This is an exception where this helium can be considered to be over here. So we have the 1s is our first sublevel that we're going to fill. Since we have 13 electrons, we're going to fill this one, and then we're going to fill this one, and then that 1s sublevel will be full. So we write 1s2. Since we have 13 electrons, we have to keep going until we get to 13. So these are full. So these are next. Now we're in row 2. And this is still S. So 2s. And there's 2 of them before it's full. So we write 2s2. Now we have 2 plus 2. If you add the subscripts, you can see how, or the superscripts, I'm sorry. If you add the superscripts, you can see how many electrons we've distributed. So far, 2 plus 2 is equal to 4. So we have a ways to go. So we've done the 1s2, 2s2. If you keep counting up the periodic table, so after beryllium comes boron. Now we're still in the 2, the second energy level, but now we've moved over here to the P block. So we will add 2s, or 2p, 1, 2, 3, 4, 5, 6. So we will add 2p since we're in the second row, P block, and we passed all 6 of those electrons. Now, instead of 4, if we add 2 plus 2 plus 6, we have 10. So we need to keep going. After that, we've filled out the second row, so we come over here to the third energy level. Start in the S block, so 1, 2. We're going to go past both of those. So now we're in the third row, or the third energy level, the S block again, and we filled both of those. If we add all of our electrons, we now have 12. So we just need one more to get to our 13. The S block is full though, so we have to come over here to the P block. This is still the third energy level, so we write 3p1. So that P block is not full, but it gives us our 13 electrons that we have for the aluminum. 2 plus 2 plus 6 plus 2 plus 1 is equal to 13. So the electron configuration of aluminum is 1s2, 2s2, 2p6, 3s2, 3p1.